So what I want to do is I want to measure the slant of a line. Okay, I want to know how fast is the line going up or how fast is the line going down. And so what that is called for us is called the slope of a line. Okay, so slope, kind of just the intuitive definition of it, is it's a measure of the slant of a line. So I'm going to show you on this grid right here what we're actually measuring when we calculate the slope. So what I'm going to do is I'm just going to identify just two random points. I'm not even going to give them numbers because it really doesn't matter what they are. So I'm going to call this one, I'm going to put a point right here. I'm going to call this one X with a little 1 subscript, Y with a little 1 subscript. The little subscript is just telling me that it's the first point that I care about. Okay. And that's going to differentiate it from this point up here. There's nothing special. I have no mysteries, no secrets. I'm just picking two different points on the Cartesian plane. And then this right here is the line that joins them. So I want to know, is there a number or is there a way that I can calculate a number in order to describe that slope, how that line is changing as I go from left to right? Now, again, I know you've seen this before, so I'm probably, most of this is not something that is new. I'm probably reminding you or of stuff that you've seen before. So we did not get to choose this. This was chosen for us, but the slope of a line that goes through these 2 points is defined as a ratio. Does anyone remember? You don't have to give me the actual how we calculate it. Does anyone remember how we remember the ratio? Slope is what divided by what? Rise over run. Yes, the slope is the rise of the line divided by run. And to be quite honest, it was probably Rene Descartes that made that. That was arbitrary. He could have said run over rise is slope, but he didn't. And so we're stuck with the results. Okay, it's rise over run. So then how do I calculate those things? Well, that's great. What rise is referring to? Rise is referring to this right here. I'm just going to make a nice little dotted line. Okay. This is the rise of the line. It's how much the line has gone up or down between those 2 points right there. So how can I calculate that? How can I put a number to the rise of this? Any ideas? No? That's okay. That's why I'm here. Okay, great. You make me feel useful. So if I want to calculate how far the line has gone up, okay, what the elevation change, if you're climbing a mountain, you're on the mountain trail, okay, how steep is that? If I want to know how far up, what I'm going to do is I'm going to take the y value where I end, y2, and I'm going to subtract the y value where I begin, y1. That's how I calculate the rise. Now that you've seen that, you probably will have an easier time answering this question because the run is then how far horizontally I'm going, why I'm climbing that mountain trail. And how am I going to calculate how far left and right I've gone when I've climbed that incline? Perfect. You're going to take the x value where you end and you're going to subtract the x value where you start. Fantastic. So now I've got some numbers that I can put to this ratio. It's y2 minus y1. That's the rise. That's how much I've changed in my elevation. Divided by x2 minus x1. That's how far left or right I've gone. Now, a question you might have, you go, Perkster, does it matter which one I call x2 and y2 and which one I call x1 and y1? And the answer is absolutely it does not. Okay, so or you could say that the rise is y1 minus y2 divided by x1 minus x2. It absolutely does not matter which way you go on that. The only thing that does matter is consistency. Whatever point is your y2, make sure you're using both the x and the y. Whatever point is your y1, make sure they're in the same place. Okay, that's the only mistake you can make when you're calculating the slope. Okay, well, here comes our first problem. Let's put some numbers to this and use this definition of a slope. So I'm just gonna raise up a little bit. And so example 1. Example 1 says, let's go ahead and calculate the slope of the line that goes through these 2 points, -1, -7, and 3, 4. Okay, fantastic. So my slope was given by the letter m. I don't know why it's m. Probably has something to do with Latin or French because Rene Descartes was French. but we're just going to call it m. And so it's the change in the y value. So you tell me, you get to define this for me. What do you want? How do you want to calculate the rise? What minus what? Okay, which one do you want to be the y2? You tell me. 4, okay. 4. Okay, so y2, 4 minus, and what am I subtracting? It's 4 minus what? Negative 7. Don't forget that this 7 has a negative attached to it. This subtraction sign is the part of the slope formula. 4 minus negative 7. Now, I'm gonna do this on this one problem. I'm gonna do it both ways so that you can have utmost confidence that it doesn't matter. If you are working ahead and you said, I'm gonna do negative 7 minus 4, that is a perfectly fantastic first step. Okay, either one of those two things is fine. Okay, I'm gonna do this one problem both ways, and then all you need to know is that we will always end up with the same answer. Okay, so if you are a 4 minus negative 7 person, what is your run? How are you calculating it? 3 minus negative 1. Perfect. I appreciate that. If you were a negative 7 minus 4 person, how are you calculating the run? Perfect. Just have to be consistent with your x2s and your y2s. Okay. Does everyone see what the point that I'm trying to make there? We okay? Regardless of how you do it or I do it, we should have the exact same answer with the exact same sign. Okay, so if we do this, 4 minus negative 7, how can I rewrite 4 minus negative 7? It's what? 4 plus 7, so it's 11. And then 3 minus negative 1 is 3 plus 1 or 4. So my slope is 11 over 4. Over here, would I get the same thing? Well, let's see. Negative 7 minus 4 is negative 11. Negative 1 minus 3 is negative 4. And a negative divided by a negative is positive. You get the same thing either way. And what's more important to me is that we understand what this is telling us, because we're going to use this to have a nice, quick, hopefully clean way to graph in just a few minutes. This is telling me on my line that I am changing 11 units in the y direction, because it's rising, 11 units of rise for every 4 units of run. That's my ratio. Okay, those are the steps that we're climbing. What I would like you to do, exercise 1, right next door. I'm going to give you 30 or 35 seconds. Go ahead and calculate the slope of the line in exercise 1. All right, how am I going to calculate my rise? Somebody give me my subtraction. Okay, I'm going to go with that. 5 minus 2 is the first thing I heard, so that's what I'm going to do. So if you were a 5 minus 2 person, that's your rise. How do you calculate the run? Perfection. Well done. Negative 5 minus 3. Okay, so either way you did it, you should end up with the same thing. 5 minus 2 is 3. Negative 5 minus 3 is negative 8. So that tells me that this line goes 3 units in the y direction and then negative 8 units in the x direction. Negative 3/8 is the slope. Questions, comments, concerns, conundrums? I'm trusting you to please ask me questions. Okay, I can only answer them if you ask them. Okay, exercise 2, same thing. Calculate the slope. All right, somebody give me the expression I'm going to use to calculate the rise of this line. Okay, sounds great. 4 minus -6. I appreciate your helping me out there. 4 minus -6. So this is my y2 minus that negative goes with the 6. So don't leave that off. So given that, how do I have to calculate the run now? Excellent. Appreciate that. 3 minus -4. Well said. And so 4 minus -6, that becomes 4 plus 6. That's 10 in the top. 3 minus -4 is 3 plus 4, or 7 in the bottom. So 10 over 7. My line is going 10 units in the y direction for every 7 units in the x direction. We doing okay? Kind of got a little conception of what slope is so far. It's a measure for how fast the line's going up or going down. It's the slant of the line. Okay, well now it's time for an amazing demonstration. Gonna blow your minds right here. So what we're gonna do is we are going to find the slope of this line right here, y equals 5x plus 3, by finding 2 points. Now, some of you know where I'm driving at here because you've seen this before, but I'm assuming you haven't. So we're going to find 2 points, and we're going to determine the slope of this line. So x and y. So I'm going to first pick the x value 0. I have a reason for picking that. But somebody else give me your favorite x value. What do you want to plug in? 2. Great. Fantastic value. So I don't have a super amount of room here, but if you need me to write this down, I totally will. But when I plug 0 in, what happens when I plug 0 in? What do I get as my y value? 3. 5 times 0 is 0, plus 3 is 3. Everybody tracking with me? Am I losing anybody on where I got that value of 3? Okay, how about 2? When I plug 2 in, what is the y value when I put 2 in on the right side? 13. 5 times 2 is 10, plus 3 is 13. There's my 2 points. Now, if you don't believe me that we would always get the same result, if somebody else wants to plug in another x value and do the slope with 2 different points, that's totally fine. But if you trust me, then everybody's going to get the same slope. So slope is going to be equal to my change in my y values, which is going to be 13 minus 3. I'm just going up the ladder right here for my change in my y values. So I'm going to go up the ladder here for my change in my x values. So I'm going to have 2 minus 0. What's 13 minus 3? Yeah, I'm just making sure you're awake. It's 10. Thank you. And then 2 minus 0 is 2. And 10 divided by 2 is 5. So here's my question. Okay, and this is probably what those of you who've seen this before, you're expecting. This number 5. Do I see the number 5 in the equation that I started with anywhere? Yes. Where is it? It's right in front of the x. That is right. This is not an accident. This number in front of the x, that is the slope, okay, of our line. We also got something else because of the value I picked. You tell me, this is review. When I plug 0 in for the x value, what does that point call? When I plug 0 in for the x value, it's the y-intercept. Yes. Do I see a 3 in the equation? Yes. Again, that's on purpose. Okay, that's the y-intercept. The reason I did this amazing demonstration for you is to introduce you to what's going to be your good friend for the next couple of sections. When a linear equation in 2 variables is solved for y, what you have is called the slope-intercept form. Now, math people are not super creative when they name things. Do you know why they call that equation the slope-intercept form? It tells you the slope of the intercept. Yes, math people are very direct people. We can generalize the slope-intercept form like this. It's y equals, that's the key. It has to be solved for y. Y equals m times x plus b. B is just the letter math people use for the y-intercept. The m, the slope, is always in front of the x. The y-intercept is always the number added on. But keep this in mind. If you need to make yourself a little asterisk of this for your notes, it has to be solved for y to determine the slope and the y-intercept. All right, let's flip to page 2. So what I've given you here on the top of page 2 is, for some reason, oh, there we go. Okay, my recording was just way behind there. Sorry. Okay, so what I've given you on example 2 is I've already solved the equation for y. Okay, we're going to take this in little steps. So by looking at this equation, what is the slope of the line I've given you? 2/3. Okay. What is the y-intercept? -5. I'm going to write that as a point because it is a point. The x value is 0. The y value is -5. Wonderful. All right, exercise 4. We're going to do this in steps, and then we'll come back and do the second part of example 2. I want you to take 20 or 30 seconds, identify the slope and the y-intercept of that problem, please. All right, what's the slope of that line? Oh, which exercise did I tell you to do? Did I tell you to do the one right next door? Yeah. Yes, I should have numbered them better. That's my fault. I apologize. If you did the one down below, I totally understand because that makes more sense. But this one's on the screen. So what's the slope of this line right here on the screen? Okay, -1/4. And then what's the y-intercept of the one on the screen? Okay, 0, -3. Fantastic. Okay, so that's all the information that we need to graph a line. Okay, and that's why I bring this whole thing up. So I'm going to go back to example 2, the one on the left. When you want to graph your line using the slope and the y-intercept, the first thing you're going to do is you're going to plot the point, the y-intercept. So I'm going to plot 0, -5. So I'm going to go down 5. I'm going to make a dot right there. Okay. Have I lost anybody? Are you with me? Okay. I can't say this enough times, and I know you don't trust me yet. You don't really know me. If you have a question, ask a question. There's no reason to sit here for 1 hour and 15 minutes lost if you don't know what, if we could answer the question earlier. Okay. All right, so now the slope is 2/3. So remind me, the 2 represents what direction? The rise or the y direction, and the 3 represents the run or the x direction. So what this says is from that point, I'm just gonna keep counting 2 in the y, then 3 in the x, and I'm gonna make another dot. So here we go. This is a lot of fun. It's very relaxing. 2 in the y, 1, 2, 3 in the x, 1, 2, 3, make a dot. Then do it again. 2 in the y, 3 in the x, 1, 2, 3. I'm having such a good time. I'm gonna do it one more time. 2 in the y, 3 in the x, make a dot. There we go. And now I'm going to connect the dots because remember my graph represents all the points, not just the ones on the grid markers. And there's my line. Just as a general thing for when you're checking your work, if the slope of a line is positive, 2/3 is positive lines always get bigger as we go from left to right. Okay, so they'll always go up like that. All right, so what I would like you to do on exercise 4, first let's make a declaration. Here's what I'm going to declare. Let's put the negative, because this is sometimes a question. That's -1/4. Where does the negative go? Let's put the negative with the 1. So let's call that -1/4. And then I'll show you it's the same thing if you would put the negative with the 4, but let's just do that for now. So go ahead and graph that line. Okay, what am I going to do first when I go to graph this line? 0, -3. Fantastic. I appreciate that. So I'm going to do that right here. And then I declared, this is not a declaration you have to make, but I just wanted us all to be doing the same thing. Put the negative with the 1. So the -1 means which way am I going to go? Down. The negative y direction is down. So I'm going to go down 1. And then the 4 means I'm going to go right 4, +4. Yes. Down 1, 1, 2, 3, 4. And you could do it again, but then we're going to go off the grid. Now, you might be saying, well, hey, Perkster, could I have put the negative with the 4? And my answer to you is going to be, yes, you certainly could have. So I'm going to put 1 over -4. So I'm going to go back to my y-intercept. If you had done that, if you have 1 over -4, what is the 1 telling you to do? You go up, and then the -4 says what? 1, 2, 3, 4 to the left, and then up 1, and then 1, 2, 3, 4 to the left. Do all those points line up? Yeah, they're all on the same line. So it doesn't matter if you put the negative with the 1 or the negative with the 4, it's still a negative slope. It's still the same line. And here is that line. So that is fantastic. There's no wrong thing. Now, I'm going to ask you a quick question because, again, I try to ask you questions that are the common mistakes I see so that we can hopefully avoid them. What if I did this? What would be the problem if I saw -1 over 4 and said, you know what? I'm going to put the negative with both when I do it. What have I done? Now you've made it positive. You've changed the slope. Okay, so pick your favorite, either the numerator or denominator. So this right here would be the wrong thing to do. If that wouldn't have occurred to you, then fantastic. You don't need to worry about that. All right, slide down on the page to exercise 3, which we've done out of order. Do the same thing. Identify the slope, identify the y-intercept, and then graph that line, please. All right, so what's the slope of this line that you identify? 4 over 3. What's the y-intercept? 2. Okay. So once again, I'm going to do the y-intercept first. So I'm going to go 0, 2 right there. And so help me out. What's the 4? What is it instructing me to do? Up 4, it's the y direction. And what's the 3 instructing me to do? To the right. 3, it's the x direction. So +4, 1, 2, 3, 4, +3, 1, 2, 3, make a dot. We do it again. 1, 2, 3, 4, 1, 2, 3, make a dot. There's my 3 dots. By the way, if my third dot, because I like to do 3 because I miscount because I can't see, I'm old. If I was to run off the grid, what else could I do from here to get another point on the line? Yeah, you could make them both negative because a negative divided by a negative would be positive. So you can actually go down 4 and back 3 if you needed another point. Okay, so that's always an option if you need more space. We had just enough space on this problem right here, so there's my line. I forgot to mention our last problem, but just notice positive slopes get bigger as you go from left to right, and then our computer's struggling a little bit here today. And then I'm going to pause it, see if that helps. All right, so I'm going to see if we get caught up here. It doesn't look like I'm going to have to start a new recording. Anyway, the one we did up at the top, it's negative slope. And what's happening with that negative slope? Where's it going? It's going down. Okay, so just knowing that. So let me stop this. Yes, I want to.